Welcome students. So today we will discuss invariants, and myself is Dr. Amanpreet, PG Department of Mathematics, Khalsa College, Patiala. So first article is, if an expression s in xy changes to an expression s dash in x capital X capital Y by a transformation of coordinate axes, then an expression in the constant of s which does not change by the transformation is called an invariant for the transformation. So see here, we know that if the origin is shifted to hk without changing the direction of the axis, then we have x is equal to x dash plus h and y is equal to y dash plus k, where x dash y dash are new coordinates of the point whose old coordinates are x and y. If the axes are rotated through an angle theta, then we have x dash is equal to capital X into cos theta minus y sin theta, and y dash is equal to capital X sin theta plus y capital Y cos theta, where x is equal to x cos theta minus y sin theta plus L, and y is equal to x sin theta plus y cos theta plus m if we shift and rotate together, which are equation of general transformation. So let under this general transformation, s is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c change to s dash a dash x square, this is capital X, 2 plus 2h dash capital xy plus b dash capital Y square plus 2g dash capital X plus 2f dash capital Y plus c dash. Main invariants under this transformation are t is equal to a plus b, called the trace. Second, delta, which is equal to h square minus ab, called the discriminant. And third one is theta, which is equal to determinant of a, b, c in diagonal, hgf, and similarly hgf in the upper and lower triangle, which is equal to abc plus 2fgh minus af square minus bg square minus ch square. So student, these three are the points which we want to discuss, the main invariants. So invariants, first invariant is t, the second invariant is delta, and third invariant is theta. This is capital theta. So in this chapter, in this topic, we see that whether trace is invariant, whether delta is invariant, whether theta is invariant or not. So article is, show that for s is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c, the quantities t and delta are invariant under any one of the transformation of the coordinates. So first is the shifting of origin and second is the rotation of origin. In shifting of origin, let the origin be shifted to x1 y1. So we have x is equal to x dash plus h is here x1, and y is equal to y dash plus k, and k is here y1, where x dash y dash are new coordinates and xy are old coordinates. So s is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c, and when we shift transform, this is s dash is equal to a into x dash plus x1 square plus 2hx dash plus x1 y dash plus y1 plus 2 plus b into y dash plus y1 square plus 2gx dash plus x1 plus 2f y dash plus y1 plus c. Then when we see, this is a dash is coefficient of x dash square, h dash is equal to 1 by 2 coefficient of x dash y dash, and b dash is equal to coefficient of y dash square. So a dash is equal to coefficient of x dash square. So here coefficient of x dash square is nothing else, it is a, and coefficient of this h dash is coefficient half coefficient of x dash y dash, which is also equal to h, and b dash is coefficient of y dash square is b. So trace is equal to a dash plus b dash, which is nothing else, it is equal to a plus b, which is old trace, and new delta is equal to h dash square minus a dash b dash, which is nothing else, because h dash is equal to h. So that means h square minus ab, that is old h, and b dash is equal to coefficient b. So t and delta are invariants here. Now rotation of axis, case 2. Let the axis be rotated through an angle theta without changing the origin. We have x is equal to x dash cos theta minus y dash sin theta, and y is equal to x dash sin theta plus y dash cos theta, where x dash y dash are new coordinates of the point whose old coordinates are x, y. So s is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c transform into, students, here we put x is equal to x dash cos theta and minus y dash sin theta, and y is equal to x dash sin theta plus y dash cos theta. When we substitute this, then again we see that what is the coefficient of x square, what is the coefficient of xy, what is the coefficient of y square, and we write a and b and h. So see here, so we see that x trace is equal to again a plus b, and delta is equal to h dash h square minus ab. So it's very easy for the students to discuss this, to just simplify this. Now come to the next one, is example 1. Show that t, delta and theta are invariant and when the equation of the curve 4x square plus y square minus 5x minus 2y is equal to 0 is transformed to another by shifting the origin to the point 1 minus 1 without changing the direction of the axis. What we do? So here the question says that we want to find t, delta and theta and show that they are invariant. So here 4x square plus y square minus 5x plus 2y is equal to 0. So comparing it with the general equation, we got a is equal to 4. Here mixed term is 0, so xy term is 0. So h is equal to 0, b is equal to 1, g is equal to minus 5 by 2 because 2gx. 2fy is equal to 2f is equal to minus 2, so f is equal to minus 1 and c is equal to 0. Trace is equal to a plus b, that is 4 plus 1 is equal to 5, and theta is equal to h square minus ab, that is 0 minus 4 into 1, that is minus 4. And theta is equal to abc in diagonal, fgh in upper triangle and fgh in lower triangle. So 4 1 0 minus 1 minus 5 by 2 0 minus 1 minus 5 by 2 and 0. So when we operate this, when we expand this determinant, we got minus 41 by 4. So now come to the main part, the new origin. Now shift the origin, that is 1 and minus 1. So compare it with h and k. So h is equal to 1 and k is equal to minus 1. So putting x is equal to x dash plus h and y is equal to y dash plus k. So what we got? 4 into x dash plus h square plus y dash minus y square minus 5 into x dash plus h minus 2 into y dash minus 1 is equal to 0. So on simplification on simplification of this equation, I got 4x dash square plus y dash square plus 3x dash minus 4y dash plus 2 is equal to 0. So here a dash is equal to 4, b dash is equal to 1, h dash is equal to 0, g dash is equal to 3 by 2, f dash is equal to minus 2 and c dash is equal to 2. Just comparing it with the second degree equation. So trace is equal to a dash plus b dash, that is equal to 4 plus 1, which is equal to 5, which is the trace of old one. And then theta delta is equal to h dash square minus a dash b dash, which is h means 0 minus 4 into 1, that is minus 4, which is the old delta, and theta is equal to a dash b dash c dash f dash g dash h dash f dash g dash h dash. I put all these values and expand the determinant, and I got minus 41 by 4, which is equal to old theta. So t, theta and delta are invariant when the origin is shifted to 1 and minus 1. So come to the next one, another example. Show that if ax square plus 2hxy plus by square is equal to 1 and a dash x square plus 2h dash xy plus b dash y square is equal to 1, represent the same conic and the axes are rectangular, then a minus b square plus 4h square is equal to a dash minus b dash square plus 4h dash square. So how we solve this? Consider the equation ax square plus 2hxy plus by square is equal to 1 and a dash x square plus 2h dash xy plus b dash y square is equal to 1. Now 2 is transformed of 1 under some transformation of x's. Okay. Then trace of first is a plus b, trace of second is a dash b dash, and delta of first is h square minus ab, and delta of second is at my h dash square minus a dash b dash. So what we want to show that? We show that these two equations are same. So I square first one, a square plus b square plus 2ab, and this side also a dash square plus b dash square plus 2ab, and second one multiply with 4, and now adding these two. On adding, so a square plus b square minus 2 plus 2ab minus 4ab, that is minus 2ab plus 4h, and a dash square plus b dash square plus 2a dash b dash minus 4a dash b dash becomes minus 2a dash b dash plus 4h dash square. So I got a minus b square plus 4h square is equal to a dash minus b dash square plus 4h dash square. So student, these two examples are there. Next we have exercise, and exercise is, first question is, show that s is equal to this, theta is invariant under one of the transformation of coordinates axis. So that means you can either rotate or you can shift. We want to show that theta is invariant. We already show this as an example. Show that for all position of axis, so long as they remain rectangular and the origin is unchanged, the value of g square plus f square in the expression is constant. So this is for your home assignment. If you find any difficulty, you can ask me and do these two questions. Thank you.